Hello, boys and girls. Today we're going to talk about the commutative property of multiplication. It's a big, scary word, but I promise it's not hard at all. Let's figure out what it is and how it works. All right, let's start with what is the commutative property of multiplication. Let's talk about commuting. To commute means to move. It means to go from one place to another place, to move. The same rule applies with commutative property. It means that you can move any numbers in your multiplication equation around to any order, and the answer is gonna be the same answer. A fun way to remember this is by saying flip it, switch it, the answer's terrific. Let's say it together now, okay? Flip it, switch it, the answer's terrific. Yay, good job, guys. Again, the commutative property means that you can take any numbers that you're multiplying and you can flip-flop them around. You can move them around from place to place and still get the same answer. Let's see how this works. Here on my screen, you see some apples, right? Let's count how many red apples we have on this picture. We have 1, 2, 3, 4, 5, 6, 7 red apples. Now we're going to multiply it by how many green apples? 1, 2, 3. Good. 7 red apples times 3 green apples. And that equals, can anybody tell me? Right, it equals 21. Now, we're going to look at this side. We've got our equal sign in the middle, which means these two problems are the same. Except you can see that on this side, I flip-flopped the apples. Now we're going to start with how many green apples? 1, 2, 3 green apples. And we're going to multiply it by how many red apples? 1, 2, 3, 4, 5, 6, 7. Good. Right. So what's 3 green apples times 7 red apples? Who can tell me? Yes, 21. Now you can see they're the same. 7 times 3 equals 21. And then we're going to commute. We're going to flip it, switch it, make it terrific. 3 times 7 is 21. See, you can put them in any order and they're going to mean the same thing. Let's see how this works with arrays, boys and girls. Remember, we started working with arrays. What are arrays? Yes, pictures to help you solve problems. Let's look at this one first. We've got 3 times 4. Remember, 3 groups of 4 apples. 1, 2, 3 groups of 1, 2, 3, 4 apples each. Right. What's 3 times 4? Who can tell me? Yes, 12. Now let's look at this side. 4 times 3. See, we flip-flopped our numbers. We flipped it, switched it, and it's still terrific. That means we have how many groups? 1, 2, 3, 4 groups of 1, 2, 3 apples. Good job. Now let's do some multiplying. What's 4 times 3? Yes, 12. 3 times 4 is 12. Flip-flop. 4 times 3 is 12. Good job. They equal each other. They just look a little bit different. Now, how does this work in real life? Okay, let's say you have 8 donuts and you want to share them between 3 friends and you. 3 plus 1. 3 friends plus you equals 4 people. How many donuts are you going to give each person? So we've got to figure out how to sort 8 donuts among 4 people. All right, so we could do 2 groups of 4 because we've got 4 friends, and that would give us 8. 2 times 4 is 8. Or we could flip it around, 4 groups of 2, 4 people. 4 times 2 is 8, right? So you can see the 2 and the 4 switch places. Now we've got 4 and 2, and they both equal what? 8. Good job. Your turn. Let's get some M&Ms and try it out for ourselves. What I want you to do is I want you to come up and get some M&Ms, and I want you to create 2 arrays using the same numbers, 3 and 2, but you're going to put them in different orders, okay? So we're going to put the commutative property into practice here, and I'm going to give everybody 6 M&Ms, and you're going to arrange them in 2 different ways. Let's look at my example if you need some help. Here I did gummy bears because I love gummy bears. They're my favorite. And I'm going to do 5 groups. 1, 2, 3, 4, 5 groups of 1, 2 gummy bears each. 5 times 2 is 10. That's right. 5 times 2 is 10. Now I'm going to make it look different, okay? Instead of 5 groups, I'm going to give myself 2 groups. 1, 2 group. And each group is going to have how many gummy bears? 1, 2, 3, 4, 5. That's right. 2 groups of 5. What's 2 times 5? Yes, it's 10. Good job. So you can see here, 5 times 2 is the same as 2 times 5. It just looks a little bit different. Now it's your turn. Come up and get your M&Ms and show me your examples. Show me your arrays. Excellent job, boys and girls. Now we're going to do some practice questions without the M&Ms. You can eat them. I know you want to. Go for it. Have a little snack, and then we're going to do some math. All right, here's what we're going to do. We're going to solve the problems that I have on this side, okay? 6 times 2 and 2 times 6, 7 times 3 and 3 times 7, 5 times 4 and 4 times 5, 8 times 2 and 2 times 8. You can go ahead and write them down in your notebooks because that's where you're going to solve these problems, okay? So once you have them written down, go ahead and solve the multiplication problems. And then I want you to tell me, do they have the same product? Who remembers what the product is? That's right. The product is the answer to a multiplication problem. So go ahead, write down the questions right here, and then tell me if the 2 groups, if the group of 2 have the same product. Yep, and here's what we found, boys and girls. We found that no matter which way, which order the numbers are in, they're going to equal the same thing. 6 times 2 is the same as 2 times 6. They both equal what? Yes, 12. How about 7 times 3 and 3 times 7? What do they both equal? Yup, 21. Good job. How about 5 times 4 and 4 times 5? What do they equal? Yes, 20. Good job. And last but not least, 8 times 2 and 2 times 8. What do they equal? 16. Good job, boys and girls. So do you see now how it doesn't matter which way you put your numbers? You can flip it, switch it. The answer's terrific. Multiplication works both ways. You can flip it around, you can move it around, and it's going to equal the same thing. Good job, boys and girls. Let's move on to something else. Thank you.